talking about distinguishable. All right, if we want to look at distinguishable permutations, we have a set of n objects, and you may already have some of this in your notes, but n objects, and it has n sub 1 of one kind of the objects, n sub 2 of another kind of the objects, and n sub 3 of a third, so on. The number of distinguishable permutations, distinguishable or distinct, distinguishable, is n factorial over n sub 1 factorial times n sub 2 factorial times n sub 3 factorial, all the way down to however many you have, like kinds. And so if we had these letters, AA, EEE, J, P, P, R, and I wanted to find the number of distinguishable permutations. How many letters are we dealing with here? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So it's going to be 9 factorial. How many A's do I have? 2. How many E's? How many J's? Do I need to put that? It's just times 1. How many P's?
2.
And how many R's? So if we wanted to, we could put those 1 factorials, but we don't have to. And it doesn't matter if they're in order or not.
If we were taking a test and we didn't put the 1 factorial, would you take anything off?
No. No, because 1 factorial is just times 1. So if we're going to simplify this, we know we have 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial. And I'm stopping there because that's the highest factorial I have on the bottom. Okay, so that cancels with that one. I could keep going, 3 times 2 times 1, but 3 times 2 times 1 is going to cancel out. Now, what is 2 factorial times 2 factorial? 4. So that cancels with this. And we have 9 times 8 times 7 times 6 times 5, which should be 15,120. So just a quick review of distinguishable permutations. We talked about it briefly last class, but just another example of distinguishable permutations. Now with permutations, order is important, but sometimes order is not important. And if order is not important, then we are going to use combinations. With a combination of n elements, taken n at a time. Order's not important. Just an example, if we're looking at combinations, ABC and BAC are equivalent because it doesn't matter about the order. If I cared about order, then I would have a permutation. let's look at an example that's got, this is in elements taken in at a time. I want to know in how many ways can I choose 3 letters from A, B, C, D, and E? How many different ways can we choose 3 letters from A, B, C, D, and E? Take just a minute and see how many different ways you can choose those 3 letters. So if we choose A, B, C, then I don't want to do BCA. Okay? So we could choose ABC. What else could we choose? ABD. And we could choose ABE.
So is it 12?
BCD,
We could choose
BCD.
ACD. Well, let me do it over here. We could choose ACE,
AD.
Oh wait, no, it's not.
or we could choose ADE. Okay, so have we used every possibility with A?
70?
No. Have we chosen every possibility that has an A in it?
Yes.
Okay. What about, starting with B?
BC.
B, C, D?
Is it 30?
No.
BCE.
B, C, E?
Could you do BCA?
Okay, I already have A, B, C, so I don't want to do BCA.
Oh, so you can't do it?
You can't use
All right.
the A. The A is.
So we have,
You can't use A? Oh.
can't use A again.
Because
Anything else with B?
No.
Nope.
BDE.
BDE.
Write it out, let's just do math.
Okay. So we have 1, 2, 3, we have 9. Do we have any more?
I got 9, including CDE.
So how many is that?
2, 4, 6, 8, 10.
10. There's 10 different ways.
That's 2, right?
10 ways.
2.
Now, I would guess you don't want to list those out every time,
No.
especially if you had 10 letters to choose from and you only wanted 3 at a time.
You're gonna tell
Order
us
doesn't matter.
sense now. Okay.
This is a combination. Order does not matter with a combination. It would with the permutation. So permutation, you could have ABC, BAC, CBA, but this is a combination where order doesn't matter. So the formula, when you have n elements taken in at a time, the combination of n elements taken in at a time is in CR, where that equals n factorial over n minus r factorial times r factorial. So if we go back to that previous example, we had 5 letters taken 3 at a time. So that would be 5 factorial over 5 minus 3 factorial times 3 factorial. So let's see if we get 10 there.
No.
Okay, so we have
It's about Matthew.
5 factorial over 2 factorial times 3 factorial.
It's a bomb for your country. I'm not.
All right, so here our 3 factorials cancel. 2 factorials, 2 times 1, so 2 goes into 4 twice. And again, we get 10. Formula's a little bit quicker than listing all the different ways. All right, so let's see how many different ways can two letters be chosen, and how many ways can two letters be chosen from A, B, C, D, E, F, G. Standard poker hand is 5 cards. With a, if it's dealt from a pack of 52 cards, how many different hands are possible? Well, we know it's going to be combination. So there's the little formula thing. The formula thing. So we would have 52 factorial over what?
I have the shortcut.
I know, I don't, just hush. 47 factorial.
Is it 2,598,000? Oh.
Yes.
I like the shortcut.
But you need to know what the process is if you didn't have your calculator.
Yeah.
We could just always have the calculator.
But that's
You
not
never
right.
did it home without the calculator.
With the exclamation
The
point?
calculator is for head. It's
Yeah.
factorial.
My
I don't
brain
have
is
to write
like,
all
you
this
always
down.
have a
Wait a minute, I'll show y'all.
Oh my
But you
God.
need, shh, you need to know how to do this if you didn't have a calculator.
Well, I just imagine that I will have to calculate it.
All right, one more.
Okay, I got it.
We have a 12-member team.
What's NPR?
National Public Radio.
What's sport? Oh, and this is the.
A 12-member team, we've got 10 girls to choose from and 15 boys to choose from. But the team must have 5 girls and 7 boys. This is what we have to choose from, 10 girls and 15 boys to choose from, but we have to choose 5 of those 10 girls and 7 of those 15 boys. Order doesn't matter. So we know we're going to have 10C5 for the girls on the team. That's the number of possible outcomes for the girls, times the number of possible outcomes for the boys, which is 15C7. Because we've got two different possible outcomes, and when we have 2 possible outcomes, we multiply them together. Goes back to what we did the other day. Okay, so figure out what that is. How many different ways could we form a team? How many possible ways could we get a team?
1,621,600.
I don't think so. Yes.
1,621,000.
That's what
That's what I got also.
Okay, what did I do wrong? Okay. Let me see. 1,621,620? Yes, that's correct. I just didn't have the answer on my paper. That's why it kind of startled me there. 1,621,620 different ways that you can get a 12-member team.
Oh,